Last new lesson of semester 1. Let's hear it.
Yes!
Right. Okay. All right. That is hot to trot. My feet are sweating, so I took my shoes off. I'm wearing darn tough socks. It says it right on the socks. See right there. Darn tough. These are good socks, but they're a little too warm sometimes. All right. So here we go. Last lesson is talking about graphing, end behavior of a graph. And we're going to talk again about multiplicities and degree, odd, or even, and what that means for the graph. So I clipped these out of the book. The graphs of a linear, quadratic, cubic, quartic, or quintic graphs. These are just some generic examples. And you will see, if you look at them closely, in relation to the degree and the end behavior, the degree and the end behavior, there's a pattern there, okay? And if you read the little snippet on end behavior here, it talks about, well, I guess I'll just read it. End behavior is a description of the values of the function as x approaches positive infinity. That's what this little, I'll use my highlighter. That's what this little blurb right here means. That says as x approaches positive infinity. All that means is what is happening to the graph as you are going to positive infinity. So as x is increasing, is it going up or is it going down? It's kind of what it's asking for there. Okay, so, oh, that's funny. I don't know how that, we're having technical difficulties. All right, we're back from technical difficulties. So anyway, what I was talking about was this, just understanding what this little symbol means right there. So as x approaches negative infinity, all that's talking about is what happens when the graph goes to the left. Is it going down or is it going up? Okay, so that's what all these little notations are. As x approaches negative infinity, p of x approaches negative infinity. That means it goes down. All right. So the reading a math text can be a little kind of technical symbols and stuff like that. So this is going to be hard to see on the video. I guess I kind of do some acting. I'll have to draw it. If a graph is odd degree, that means each end behavior is going in opposite directions. So like this first degree, as x goes to the right goes up, as x goes to the left goes down, right? If I skip to the next odd degree, 3, the right side goes up, the left side goes down. They go opposites. Okay, if I skip to the 5th, the right side goes up, the left side goes down. All right, if I look at the even degrees, they're both going in the same direction. They're both going up there. 4th degree, they're both going up there. And so if the degree is even, the end behaviors are going in the same direction. If it's odd, they're going in opposite directions. So my options here, we'll do a little quiz here. Okay, I'll just draw some end behavior. It'll go like that and like that. Who cares about the middle part right now? Is this odd or even? That would be an odd degree because the right side goes up and the left side goes down. Okay, what about this one right here? Is that odd or even? Odd. Why? Because the right side goes down and the left side goes up. They go in different directions. Okay, I got 2 other options right here. Odd or even? That one's even because they both go in the same direction. They both go up. All right. And the other one would be this one right here, odd or even. That's also even because both of them are going in the same direction, going down. All right. So now, crime in Italy. How do you know which way they go? How do you know if the right side goes up or if the right side goes down? That depends on the leading coefficient. So the leading coefficient is the number out in front of the first term. So if I'm just going to make something up here. Let's just say it's 2x cubed plus whoever really cares what the rest of it is. All right. goldfish bag is really loud. Anyhow, does this have a positive or negative leading coefficient? Positive, because the number out in front of the first term, which this is a cubic polynomial, is positive 2. So what that means is if you have a positive leading coefficient, that means the far right side, I just screwed up, the far right side is going to go up. Okay, so the leading coefficient tells you what the right side does. As x goes to infinity, what does y do? So this one would say, as x approaches positive infinity, p of x, which is y, also approaches positive infinity. It goes up. All right, the degree on this one is odd, so what is the other side going to do? That one's going to go down. Okay, so that would be as x approaches negative infinity, p of x approaches negative infinity. It's going down. That's kind of their symbols. That's how they show that. All right. So the leading coefficient tells you what the right side and behavior does. Okay, and then if I scroll down a little bit, this is from yesterday. This is what the middle part's going to do, and then we'll do some examples. But at the roots, so those are where they cross the x-axis, the x-intercepts. If it has an even multiplicity, it bounces back there, and an odd multiplicity passes through. Okay, let's look at some examples. 1a, let's determine leading coefficient, positive or negative. Degree, odd or even. So leading coefficient is, that's a 2, so it's positive, right? Okay, the degree is 5th power, so that's odd. So what happens to this graph if I draw a little picture? I like drawing a little picture instead of saying as x approaches infinity and y and all that. So if I draw a little picture of this, the right side, since the leading coefficient is positive, will go up, and the left side will be going down because it's an odd degree. So they go opposite directions. Okay, next one. Leading coefficient is negative, right, because of the negative 3. The degree is even. So if I drew a little picture, leading coefficient's negative, the far right goes down. And if the degree is even, the far left, the other side, does the same and also goes down. You know what I'm saying? You're picking up what I'm putting down here? You hear me clucking, big chicken. What about 2a? Odd or even? Can you look at a picture and determine odd or even? Odd because they're going opposite directions. Leading coefficient is negative. Just working backwards from the picture. This one right here, odd or even? Even. And the LC, positive. Or positivo. Okay. All right, let's go put it all together now with the roots. So here's a couple examples where they're written in factored form, so you don't have to factor them. So we just can go straight to what are going to be the roots. So in this case, we do have to do a little bit of figuring out what would be the leading term if I multiplied all of this stuff out. What would the first term be? It would be 1, and then it would be x to the 3rd power, right? So that would mean that the leading coefficient is positive, and the degree is odd. And then the roots would be what makes each factor 0. So in this case, we would have a root of -2, 3, and -5. And they all would have a multiplicity of 1. So if they have a multiplicity of 1, I don't write it. That's like implied multiplicity. So let's go and put those on our little graph here. So we got 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. I believe that covers it. Negative 5, negative 2, positive 3. Okay, this is just going to be a rough sketch. So if the leading coefficient's positive, that means that from the root farthest to the right, which is the biggest root 3, it's going to be increasing from there. The degree is odd, so the root on the far left, or the smallest root, from there is going to be decreasing. What happens at each root depends on the multiplicity. So the multiplicity is odd, it's going to pass through. So every one of these roots, it passes through, has to come back down to get to that one, right? Then it goes down, it has to have a little minimum there and comes back up to that one, and so this one would look something like that. Not exactly like that, but it's just a little sketch. Okay, so it depends on the multiplicity at the root, what happens, whether it goes through or bounces back. This next one will be a little different. What would the leading term be here? Well, it would be the product of negative 2 times x squared times x, which would be negative 2x to the 4th. That would be the leading term. So the leading coefficient here is going to be negative, degree is even, and each root is going to be negative 2 with a multiplicity of 2 this time. Hello? Come on. You won't let me right there? And then we have 3 and negative 5. So there's 3 roots, actually the same 3 that we just had, but negative 2 has a multiplicity of 2 because it was x plus 2 squared. You know, if I write that all out again down here just a little cleaner, this is going to be negative 2 times x plus 2 times x plus 2 again because it's squared times x minus 3 times x plus 5. And so what happens is negative 2 is a root twice, so we'd say it has a multiplicity of 2. So let's plot those. 1, 2, 3, 1, 2, 3, 4, 5. Wait a minute. Okay, leading coefficient is negativo. So if it's negativo, it's going to go down. If the degree is even, the other one does the same, so that's also going to go down. Oops. At the root 5, negative 5, which is where we're at, the multiplicity there is just 1, so it passes through. Comes back down to negative 2, and at negative 2, that's where I have the multiplicity of 2, so that one's going to bounce back there like that, and then it's going to come back down and pass through like that. So at negative 2, it bounces back kind of like a vertex, you know, it goes decreasing, 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 and then it stops and it goes back the same way it came, and then it goes increasing, 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 increasing. How do you know it bounces back right there? Is that what you said? Because it had a multiplicity that was even. That's what multiplicity says. So like, if you look at the root here, what makes this 0? Negative 2. What makes this 0? Negative 2 again? That has a multiplicity of 2. It shows up more than once. And then this one would be 3, and this one would be 5, and those both show up just once, so they don't have a multiplicity of, I mean, it's just 1, so you don't really say it has a multiplicity because it doesn't. If there's 3x plus 2s, it would have a multiplicity of 3, and then it would go through, but it does a little bend when it goes through, like a cubic, like the kind of the vertex of a cubic, or that. Okay. All right, I grabbed one more page for us just to do a couple more examples because this is a curveball, gets people. So multiply this out, I would have negative 2x to the fourth. Okay, so leading coefficient negative, degree even. Roots and multiplicities, we'll list these out right here. We got 0 with the multiplicity of 2. That's the one that gets people, is right here. If 2x squared or negative 2x squared is a factor, or if x squared or if x is a factor, 0 is the root that goes with that one. All right, so 0 goes with that stuff, 3 goes with that stuff, negative 5 goes with that stuff. So 3 is the other root, just has a multiplicity of 1, and negative 5 has a multiplicity of 1. So we have 0, 3, and negative 5. Degree is even, leading coefficient's negative, so this side's going to go down, the other side's also going to go down, and it's going to bounce back at 0 because it has an even multiplicity. So this one's very similar to the one I just did, except for the 0 was one of the roots. That kind of goofs people up. They forget about it. All right, last one is one that Aaron was just asking about, where we have something to the third power, so that's going to have a multiplicity of 3. So my leading term is going to be 2x to the fifth. Leading coefficient positive, degree is odd. Roots and multiplicities. I only have 2 roots here. My 2 roots are going to be 5 with a multiplicity of 3 and negative 1. And that has a multiplicity of 2. So if it has a multiplicity of 3, it's going to bend and pass through. So it does a little bend as it passes through, it just doesn't go straight through. And if it has a multiplicity of 2, it's going to bounce. Right? So pop those 2 roots on there. We have, what was it, 5 and negative 1. All right, leading coefficient positive. So that's going to go up. Degree is odd, so it goes down. And at negative 1, it bounces back. So it's going to go like that. It's going to bounce back. Then it's going to come back up here. And it's going to do a little bend. And then it's going to go through. So I just redraw mine because it has a little bend in it. It has a little bend because it's an odd degree. But it's not odd degree in 1. It's odd degree in 3. So if it's like 3 or 5, it's going to do a little bend when it hits the root. Makes that sound too. Can you make that sound? All right, that's it. Happy last lesson of the year. And so now you just got to do a bunch of studying until we get done with our finals. So let's see if I have to do push-ups today. Ready?